Hello and welcome back. In this video, we're going to talk about SSH keys and what SSH actually is. We're not going to jump into too many details because the very basic theory, the fundamental theory behind using keys to authenticate and authorize access is something that we're going to talk about in future lectures. There's actually going to be one entire lecture dedicated to this topic, but that's going to be week 9, I believe. However, we're just going to talk about the basics that we need, or you're going to need to get projects done right now. And the first thing that you're going to learn how to do is just generating keys. It's not using anything yet, so you're just going to be generating keys to authorize your access with whether it's GitHub or department servers or any servers or any application you'd like to access. The process for this usually is generating one key that it's essentially two keys, a private and public key, and the private key is going to be the key that you're going to keep for yourself and use for future authorization. So think of the private key as your password. You want to keep it to yourself. You don't want to give it to anybody else. You don't want anybody else to even read it, and you certainly don't want to transfer it over a network that you don't trust. So think of it as a file containing your literal password, not just password credentials, meaning you don't even need a username to authenticate yourself. However, there's a lot of safety measures in place to prevent your credentials from being stolen. One is that both the private and public key are hashed, which means even if someone is looking at it, doesn't mean they're necessarily going to be able to use it. You still need to have the public key set up. And the public key is something that you set up with the application or service that you're trying to use, which in this case is going to be GitHub. So whenever you generate a key, you put the public key into the application or you give it to whomever is trying to set up authorization for you, you might find yourself uh, in a situation where someone's trying to give you access to any type of resource and they ask for your SSH key, and you're supposed to just know to give them your public key. So that's basically the process. And the way you generate an SSH key to begin with is using the SSH keygen command, which we're first going to check if it exists on the server, which it does. If you're on Mac or WSL, you should still have this command, but try to do which. And if you don't, you probably need to install something like openssh. On WSL, you would just look up how to install SSH on whatever distribution you're using, which is probably Ubuntu. On Mac, you can, if you don't have it, you can probably install it via Homebrew. And I would typically prefer Homebrew over other methods of installing it. So just figure out how you're going to install SSH or OpenSSH, basically the name of the package, and that will give you not only the key generating application which we're about to use, it'll also give you the secure shell itself as a program which allows you to access a remote server or computer's shell the way I'm accessing the server Hostium right now. So that's basically what's in that package. It's there's more there. These are just the things that you'll be using more commonly. And the way you generate an SSH key, all you need to do is type in SSH keygen, and then, and this is kind of optional, but you're going to want to use an encryption standard that's fairly up to date. However, not all servers support all standards, but the one I'm going to use is it should be supported by most services and servers. And if they don't support it, you might have to just ask them what standard they're using. But standards like RSA or DSS, these are standards that are going to be that are either dropped by most platforms like GitHub or will be dropped at some point, because at some point they're no longer going to be secure, or they're going to consider them no longer secure. So that's the difference. And to specify the standard, you would do -t and then the name of the standard. You don't have to memorize this. You can write it down. You can Google it every time you do this because you're not going to be frequently creating SSH keys. You just create it once for every service you're going to use, and you're done. And the standard that's recommended right now, at least by GitHub, is ED 25519. I don't know a lot about the standard myself, but it's just a standard that's recommended to be used. And then you specify an email address or just a name. Again, this is optional, but it's probably a good idea if you do that. And keep in mind, this has nothing to do with your email on GitHub or anything like that. It's just the alias, the name that's going to be used, that's just going to be appended to the key. So feel free to use any email. I'll just use my Oregon email in this case. And once you press enter, it's going to start generating your public and private key pair that we just talked about. And the default directory in which these are going to be saved is the .ssh directory. I talked a little bit about that .ssh directory in the previous video. And by default, it's just going to save it under files with the same name as your standard prepended with ID underscore. However, it's usually a good idea to name them after something because you're not always going to be using one key. In fact, what I would recommend is just having one key for different services. And the reason for that is these keys are somewhat flexible, meaning once you add the public key to, let's say, a service like GitHub, you can also specify that, oh, this is one server that I'm going to be using for 3 months, and depending on the type of GitHub plan you're on, or what service you're using, some services allow you to even set an expiration date. So you can say, okay, I'm going to be using this key from this server for 3 months, and afterwards I just want it revoked. And it's really flexible because unlike passwords, you don't have to keep changing it and keep remembering it. You just set up the SSH key, and after a certain period of time, it will expire, or you can let it expire after a certain point of time, or just delete it from your account, and the access will be revoked. So it's a good idea to save them under a file name that makes sense for you, because again, you are probably at some point going to be using SSH for more than just Git. You could be using it to SSH into different servers, depending on what your setup is. Again, some companies have their own private Git servers, so you would probably need a different key for that. And it's again a good idea not to use the same key for multiple services for the reasons I just mentioned. So for this purpose, because I'm going to probably use this for my GitHub, I'm just going to do /home users. Just give it the same path, but do remember that you're now in the SSH keygen program, and it doesn't support pressing tab to autocomplete. So you're just going to have to type in the full path. And what you can do is just give it any name. I'll just, I don't know, I'll call it GitHub. And then press enter. And you can specify a passphrase for it. A passphrase, again, is another line of protection for you. And the way it works is every time you want to start using a key, the SSH agent is going to ask you for the password because, or the passphrase, because it needs the passphrase to unlock the key in the first place. So it's, again, another line of protection. You may or may not use it. It's completely up to you. If you trust the server and you know nobody else is going to have access to your home directory, and you could also restrict read permissions on your .ssh directory, which you should always do on shared servers. And I'll show you how to do that in a minute. But again, the root user has full privileges. So if you don't trust the root user or those that have sudo on that particular server, it's probably a good idea to have a passphrase in place just in case, because there are ways to anybody that has root is going to be able to log in as you, and then when they're logged in as you, they're able to read your .ssh directory just the same way you're able to read your .ssh directory. So as long as you're on a shared server and it's not a personal device where you don't have a lot of protection, it's probably a good idea to have a passphrase in place, just because anybody with sudo can technically log in as you. But for the purpose of this, because I'm not actually going to use this key right now, I'm just going to skip over this. And when you're done, it's just going to give you a random arc for your key and a fingerprint, but we're not going to need any of this. What we're going to do is just clear and then look at the permissions. And I'm going to talk about permissions first. So the first time you're setting up SSH keys on any computer or server, just make sure you do this step as soon as you start using SSH, which we just did. Type in ls dash, and this is something that I alias, which means in my bash RC, I alias this to a really short command that executes ls dash ltah for me, and it basically shows me, let's actually execute it. It shows me not only all my files, but their permissions, their owner, all the files, but their permissions, uh, owner, user, and group, file size, class modified, and so on. And more importantly, permissions. And of course, it shows hidden files because of the -a flag that we have there. And of course, it's sorting them in a specific way. But anyway, you could just get away, and the dash H usually in commands like ls stands for human readable. So if you look at the file sizes, it automatically converts things that are more easily readable in kilobytes to kilobytes. The same with megabytes, gigabytes, and terabytes, and so on. Now, onto what I was talking about. Notice how permissions on my .ssh directory are read, write, and execute, and the rest are cleared. And then the first D just designates that it's a directory. So if there is D, it's a directory. If not, it's just a file. And the thing I want to point out is that the rest of my directories have rewrite execute, read write execute, and then read execute. So these permissions are, there's effectively three sets of permissions. The first one, the leftmost one, is for user, meaning yourself. Read write execute this. The second one is for group, and the third one is just system wide. So the first three read write, the first three characters, the first three permissions are just for your user, and the rest is just for everyone else. And when you want to make sure that you and you alone have read permission, meaning you can see the contents of that directory, just make sure that the permissions are restricted just to user. And if you're not familiar with these, there's only technically four possible permissions for there's technically three levels of permissions. Read just means you can explore the directory, or if it's a file, read the file. Write, obviously, write access, someone can modify it. And then execute is just being able to execute programs that in that directory. And taking these permissions off is very important, and it's not something that your operating system is going to necessarily do on its own. So it's a good idea to make sure that these are the permissions for your SSH directory. And if they're not, it's probably a good idea to set them. And the way you set them is you just use the chmod command that lets you modify permissions for any given file or directory. And if it's a directory, again, we need the recursive flag, except with chmod, it's going to be capital R instead of small. And then just the user and the group, the permission that you're going to set, which you can use characters for this, but I typically just stick to the number format. So 7 is going to be 7 basically means read, write, execute. 6 means read, write, and 4 means just read. And as a result, you're going to end up typing in 3 characters instead of just 3 numbers, between 3 numbers that are either 4, 6, and 7 instead of just all these characters. So 700 means full permissions, full privileges for user, and nothing for the rest. So that's what I'm going to do for the directory.ssh. Now, notice if I set it to 777 and run this command again, you can see that there's this directory has all permissions, which means every other user on this file system is going to be able to read, write, and execute whatever is in that directory. And this is the least safe, but it's the most open. And typically with directories that contain sensitive information, you want to be careful with that. So I'm going to just set it to 700. There we go. And again, keep in mind that administrators, those that have root access, are able to override all of this. They can change even the ownership from your user and group to root or to some other user, as well as the permissions. So as far as you're concerned in Linux, those that have sudo or root access are effectively God. Now let's talk about the contents of the directory. I'm just going to clear this, and I hope this was clear why you're supposed to set permissions for your .ssh. And again, this is not limited to a server. This can be on your local computer. It can be on your Mac. If you're on Linux, it can be your home directory in your Linux box, or it can be WSL on Windows. Now let's take a peek inside .ssh. And now you can see that the key I just generated is here as a pair. There's a file named GitHub, which is going to, the contents of which is just your private key. So there's really no use in even looking at this, but if you want to look at it, sure, go ahead. But what you really need to look at is the public key, because this is the key that you're going to put into your GitHub account to give permission for this private key to access your GitHub without needing a username and password. So essentially think of this as a new authentication protocol. SSH is the new authentication protocol. So actually, let's look at the contents of the public key. And this is basically what it's going to look like. It's going to be a standard, then the hash, and then finally the email or username or alias that we entered. And what you're going to need is copy the entire line and paste it in whatever section in the application you're using. In this case, it's GitHub. You're going to enter it into that application in the spot that lets you add SSH keys. So this is going to be one key that you're going to end up adding. So if I wanted to access my GitHub through SSH, I would do that. However, for obvious purposes, I'm not going to enter this into my GitHub right now. This was just to give you an idea. Next, I'm going to look at authorized keys. Now, authorized keys is interesting because with authorized keys, you're essentially setting up SSH keys on the device you're on right now. In this case, I'm logged into a server, which means any public key that I put in the file authorized keys, and let's actually take a look at authorized keys. Again, it's the same pattern. Any file, any SSH key you put into this file, and you typically do one key per line. So effectively, it's going to end up looking something like this, or just empty or non-existent if there are no keys. But any public key you put in this file is going to be able to authenticate and log into your user as long as they're connecting through SSH and providing the private key that was associated with it. So what this means is that on your home computer, you're able to generate keys, and then you would take the public key and put it into the authorized keys directory on whatever server you're trying to connect to, and then you'll be able to SSH into that server's terminal as yourself without needing a password. So that's basically the gist of it. However, what you probably shouldn't do, what doesn't really make sense doing, is taking the contents of a public key on the same machine and putting it in authorized keys. That doesn't make sense because you're essentially trying to authenticate yourself on the current machine with a key, which again doesn't really make sense. So just don't do that. And there's also known hosts, which is just a collection of fingerprints by different hosts that you SSH to. And this is just to keep track of hosts or remote targets that you're trying to SSH to. It just keeps track of those in case the target server changes. Again, for security purposes. I don't know too much about this, so if you're interested, you might just want to Google, but that's basically what's collected here is just fingerprints of servers that you SSH into from this machine. Now we talked about all of these. There's also another file that doesn't exist here, and that's an SSH config file. Again, I'm not going to go over this in full detail, but I encourage you to Google if you want. That would be SSH/config. Again, it's a file that doesn't exist on the server, but the purpose of this file is to set up configurations for different servers you're going to be connecting to. And the good thing about this file is that you can you can specify specific domain names or server addresses that you're going to be connecting to, give them an alias, connect them to an SSH key, and then that way, every time you're SSHing to those, you don't have to figure out which key you're going to be using or initialize an SSH agent. I'll actually just start talking about the SSH agent at this point. And let's actually start with which SSH agent. SSH agent is just a program that you need to be running to be able to use SSH keys. Think of it as a keychain. So you run an instance of SSH agent, and it is going to keep track of all the keys you add to it. And the purpose of this is your SSH keys, first of all, might have passphrases. So once you enter the passphrase, or if it doesn't have a passphrase, you just add it to your SSH agent. Then the thing that it will do is that every time you try to use the SSH protocol, SSH will automatically go through all the keys in your SSH agent and pick the one that it can use to authenticate with. So that's the purpose of SSH agent. So because we're going to need that, let me actually go ahead and generate generate a GitHub key and add it to my GitHub. So I'll just pause recording for a second. Okay, so we're back. So now I regenerated that key and added it to my GitHub so that I'd be able to use SSH to access my repositories on GitHub. However, keep in mind, you're still able to access your public repositories. As long as a repository is public, you can clone it and read it. What you cannot do is push to it or access your private repositories. So for those, you are going to need an SSH key. And the alternative is to just deal with with HTTPS. But the problem with that is it's going to try and authenticate you with your GitHub username and password every time. And that's, well, first of all, insecure, and second of all, really difficult. So SSH keys are just a good way to both achieve the security level you would want, and of course, just be able to authenticate quicker. Now, what I've done, I've set up the key, but if I want to clone any repository, let's suppose I want to clone my .files repository, which you don't need to worry about what it contains. It basically just contains my normal setup on a Unix-like operating system. But I'm just going to try and clone that. Now, again, this is the point I'm trying to make. If I try to clone by giving an HTTPS address to git clone, which means just authenticate via HTTPS, I can perfectly do that because this repository is public. However, I'm actually going to delete the directory and clone again. If I want to use SSH, which, as we've already talked about in class, you would do by doing git at GitHub and then colon username / repository. If I do this, first of all, this is the fingerprint verification that I talked about. So it's basically trying to authenticate with GitHub.com, and the first time it's just going to ask you to approve of this and store the fingerprint. So you type in yes, but then you will see that it's giving me a permission denied error because I'm not specifying which key SSH is supposed to use. And it's not just going to try and find public keys on my system. It doesn't even know how to do that. So because of this, I need to set up my private key somehow. And the best way to do this, well, I shouldn't say best way, but the way I go about it, which is fairly easy, is to just use SSH configs. And this is how. I said I'm not going to talk about SSH config, but I actually am because it's actually a lot easier using SSH config than setting up the SSH agent on your own. So what you can do is modify your SSH config. It's not going to exist initially unless you create it, but I'm just going to do this. And the way you go about it is you define hosts. So I'm going to define host github.com. And in the next line, I'm free to basically set up some properties for this. So the first one you should set up is identity file. An identity file is just you're specifying the SSH key that it's supposed to use to authenticate you with github.com. And in our case, it's home/ssh/GitHub and not .pub because we want the private key. Now this is going to work, and I'll show you. You do this, it's going to work. And yes, I set up a passphrase the second time I generated that key. So I'll just use that. And now you can see it successfully cloned. And if I go into .files and do git remote -3, again, something that we went over in the lecture, you will see that the address for the original repository is set up as an SSH handle as opposed to an HTTPS. If it were HTTPS, that would mean that every time I try to push to this repository, it would ask me for a username and password. Whereas right now, I can make any changes without having to worry about that. So as long as you're able to even clone with git@github.com, that means success. That means you were able to authenticate yourself with your GitHub account through SSH keys. However, there's a little bit of a catch to that. Suppose I want to clone my next repository, or literally do anything with Git, even pushing and pulling. Let's try to clone project 0 that I forked in class the other day. If I try to do that, it's going to ask for my passphrase again. Now, this can be a little bit difficult to have to enter your passphrase every time if you have a passphrase, which you probably should, again, on public servers. However, what I can do to get around this, and I'm just going to delete these directories because I want to clone them again, and I'm running out of repositories I can think of. An alternative to this is just modifying your SSH config again and adding this line. Add keys to agent. Yes. As long as you enable this, it will try to not only unlock your private key when you enter your passphrase, it will also add it to the SSH agent process that's running. I already talked a little bit about SSH agent, but the way you can think about it is, again, just a process that's running under your user. And that process is basically a keychain, and it will keep unlocked private keys in it for a specific period of time that you can also modify. So let me try cloning something again. Again, it's going to ask me for a key because I didn't have the option before. So let's see if it actually works this time. Let me go ahead and clone .files again. Voila, it doesn't need me to re-verify my passphrase. Here's the interesting thing that I want to show. And that's that, first of all, I want to introduce a new Linux command, and that's ps, which shows you the status of processes that are running on this computer or this machine. And usually you want to run it with these default flags. I'm not going to get into the details. And then I'm going to pipe it and use the grep command to search something in it. And that's one of the basic things that grep does for you. I'm going to grep it by my username because I want to look at processes only by my username. And if I look at these, you will see there's an SSH agent that's already started here. Now, I probably don't want this to be happening, and I think my existing configuration probably set this. And yes, the date is giving that away. So I'm just going to kill this process by giving it my process ID. So let me try this command again, and I don't have an SSH agent running anymore. And this is just saying that there's a background process. It's not saying background here, but it's just saying that my user has this process running. And again, the reason for this is that I've set up a script that gets called every time I log into this machine to either create a new SSH agent process or start or attach to an existing one. And the way it's attached is through the process ID, but I just want to kill it just to make sure that this is the effect that you will be seeing when you try this on your own. And I'm going to remove .files. I'm going to remove project 0 and try to clone again. If I try it again, it's still working. And that's basically what I really wanted to confirm, that it doesn't really rely on a separate SSH agent process running. But effectively, what ends up happening is this is all happening in my local environment, meaning if I were to log out and log back in or start even a new terminal process, it's probably going to ask for my passphrase again. And just to make sure I haven't missed anything, I'm going to use this again just to make sure that there's no other SSH process existing out there. And what I'm going to try and do to act as if I've logged out and back in again, I'm just going to type in bash and start a new bash process within the bash process I'm in. So you don't need to worry about this, but effectively what I have right now is a new bash process with a clear set of environment variables and local variables. So what I'm going to end up doing is remove, again, these repositories because I want to clone them again and proceed to um, try to clone them again. Git at github.com, username, project 0. Okay, so I guess it ends up adding the key there forever, which is kind of something that you don't want to do because, I mean, technically speaking, it's not really good because again, if someone logs into your account and it's already added to the SSH agent, then they're able to use it. So probably not something you want to do. Again, something that you probably never have to worry about. But again, it's good to keep in mind that the way it's working is that there's a process running that's keeping track of your key, and it's good to be able to limit it to a specific amount of time. But again, I'm not going to get into this too much because it's just out of scope, but everything you need to know about setting up SSH keys is probably just this, that as long as you have an SSH config and you set up your keys in this way, then there's not going to be any overlap. There's not going to be an SSH agent trying to just try all of your keys. And then there's no extra processes running there, keeping track of your keys or keeping your keys for whenever you do need to authenticate. So it's a relatively good practice to get into. And again, this is not where it ends. If you were to SSH into another machine's terminal, which I'll probably do in another video, not probably, I'll do it in another video, but it's the same process. You can add in other things like and you could even, this doesn't even have to be the real host name. You can define an alias and specify the host name as these properties. You can add other things like a proxy command, which is useful for when you're SSHing with extra firewalls. You can add in a custom username. There is a username required, which it is if you're trying to SSH. So it's a really useful file, and I would recommend learning about it and using it specifically to automate some of the process that you're going to be going through. And I'll just stop here and do another video on SSHing to servers because that's only going to be a concern for some of you who are going to be using department servers or those that are interested in knowing how to SSH into another machine.